Today we're going to talk about thermodynamics. Thermodynamics means thermo, meaning heat, okay, and dynamics mean movement or change. Okay, so thermodynamics studies the change in heat or the movement of heat. And heat is just a kind of energy that's associated with temperature. Okay? So if you have something hot and something cold, then heat will flow from the hot thing to the cold thing naturally. Okay? And it won't flow backwards unless you force it back using some sort of mechanism to push the heat the other way. All right? And thermodynamics is kind of a big word, but let me tell you right now, it's as exciting as watching ice cubes melt. And that's what we're going to do today. Okay? So, back to talking about temperature. Remember, temperature is associated with how fast atoms are moving, okay, and molecules are moving. And we are going to take a look at how fast heat can flow from one thing to another, okay? So we're going to take two things at the same temperature and watch how one thing absorbs heat faster than another. What I have here is two different kinds of materials. I have a piece of aluminum and I have a piece of styrofoam, okay? And these two pieces are both painted black, and they're supposed to look very similar, but they're going to have very different thermodynamic properties. All right? And I can check their temperature here. I have a little remote temperature sensor here that we can check out. And this says this is 75 degrees, and this is 75 degrees. So they're exactly the same temperature. Okay? What I'm going to do is I'm going to take and put these little pieces of rubber on there just to hold water, and I'm going to take a piece of ice and put it on the styrofoam. And we're going to watch the ice melt. Okay, so as you can tell, it's kind of boring. Right? That's because styrofoam does not transmit heat very well. Okay? The top of this styrofoam is cooling off wherever the ice is touching it. Basically, heat flows out of the surface of the styrofoam, and the rest of the styrofoam doesn't feel very cold. Okay? It's not cooled off that much, so I can touch it. Watch what happens when I put an ice cube on the aluminum. Boom. Okay, you can see it starts to melt right away, and that's because aluminum is very good at transmitting heat. When I put an ice cube on there, the top of the aluminum cools off because heat flows right out into the ice cube. And then the rest of the aluminum next to the top also trades its heat to the surface. So more and more heat is flowing out of the aluminum into the ice cube because aluminum transmits heat. So basically this whole block is cooling off while the heat flows into this ice cube. So let's review real quick. We have the piece of aluminum that melted the ice cube really fast, and we have this piece of styrofoam that didn't melt the ice cube hardly at all. All right? They started at the same temperature. So it wasn't their starting temperature that made the ice cube melt faster. It was that the aluminum took, the heat flowed out of the aluminum from all parts of the aluminum faster. It could get from the edges back to the middle and then melt that ice cube. Okay? That is why metal feels cooler when it's the same temperature as a piece of styrofoam. If I touch a piece of styrofoam, right, it feels room temperature kind of warm. But if I touched a piece of aluminum, okay, or metal that was still room temperature, what would happen is the heat from my fingers would flow into the metal, okay, and then that warm part of the metal, the heat in the metal would flow out to the rest of the metal and keep flowing and flowing out. And so the heat from my fingers would continually be flowing into the metal. Whereas a piece of styrofoam, when I touch the surface, I can warm up just the surface, and then it doesn't really flow into the rest of the styrofoam, and it feels like it's warmer than a piece of metal. So metals and styrofoam, when they're in the same, sitting in a room for a while, the metal might feel cold, but they're really both the same temperature.